we shall discuss an application of projectile under relative motion. But before we do that, just a small formula I would like to discuss, which we would use it there, which is connected to projectile motion. So for example, we are having a projectile which is projected with some initial velocity u at an angle theta. We would define its equation of trajectory as y is equal to x tan theta minus g by 2u square cos square theta x square. So what we call this as equation of trajectory for a projectile, and we can use it at points where we need to have like suppose this is some target which has to be struck by this projectile. So this must be having a coordinate. If we take this as the origin, so this has a coordinate x comma y. That means this distance would be x and this height of this point above the ground would be y. So that I would say that if these are x and y coordinates, so that must be satisfying this. Yeah, where for example I am saying this is a comma b. That means the horizontal distance x is equal to a and the vertical height of this point above the ground is b, y is equal to b. So if I substitute a in place of x and b in place of y, this equation must be satisfied, where theta is the angle of projection. So keeping this in mind, we shall discuss an application of projectile with relative motion. So now let us consider this application where we are having a tower of some height h and we are having two projectiles which are projected with respective velocities u and v and at respective angles of projection alpha and beta. And let us assume that they are going to hit one another at this point, which is located in such a way that its height above the ground is n, and just below this level from the point of projection from the tower, top of the tower, it is below at a height of n. Okay, this distance is n, so that I can say altogether the height of the tower is n plus n, right? And also let us also assume that horizontally they have also covered some distance in the process, and let us assume that they are horizontally away from the tower at a distance of a. Now the question is, we have to find an expression for height of the tower, right? So now, as I said, we can use directly the equation of trajectory because both of them are projectiles, and the very first thing I would consider here is the coordinates of the point at which they are meeting. Now if I see, if this is considered as origin, the coordinates of this point of hitting would be x coordinate of a and y coordinate of n. So I would rather say that this is a comma n. The x coordinate is a and y coordinate is n, right? So now the equation we have said for equation of trajectory is y is equal to x tan theta minus g by 2u square cos square theta x square. This is the general equation, normally what we mention for trajectory equation of path. Okay, so now let us apply it for the first one and then for the second one. And let us also take sign convention that upward displacement is positive and downward displacement is negative, as we have to apply sign convention. Okay, so now in the first case, the displacement between initial and final point is downwards, and I would also say the displacement magnitude is m, but sign convention followed, it would give minus. So I would say in place of y, okay, let us say this is A and this is B. This particle is B and this particle is A. So if I write it for A, so I would write the y as minus m because it's going down is equal to x. It is meeting or reaching this point by covering a horizontal displacement of x is equal to A. So I would say A tan alpha minus g by 2u square cos square alpha x square. So here the x again was A, so I would say A square. Right? Now let this be equation 1. Now coming for the particle B. The particle B which is projected from bottom of the tower, I would write the same equation for this particle when it is reaching here and the coordinates as mentioned there. But this time it has covered a vertical displacement of n, and that too in the upward direction, for which I have taken the sign convention as positive. So in place of y, I would replace it as n. It would be plus n is equal to x tan theta. Here the displacement again for this particle also is A, so I would replace it as A into tan beta. This time the angle of projection is beta minus g by 2 v square cos square beta into A square. So if I consider this as equation 2, okay. So now before we go any further, we should also know the fact that both are meeting at the same point, okay. And second thing is the horizontal component of both of them must be equal, because if they have met at one point by covering equal distances in the same time interval, that means their horizontal components must be equal. In other words, the horizontal component of this projectile, which was u cos alpha, and the horizontal component of this projectile, which is v cos beta. So I must have v cos beta must be equal to u cos alpha. This is because they both are covering equal distances within the same time interval, so both must have the same horizontal component. So that would make the denominator of the second term in both the equations to become equal. So I can replace this equation with u square cos square alpha, so that the calculation the solving of the equation becomes more easy, okay. So I will write this as n is equal to a tan beta minus g by 2 u square cos square alpha whole bracket A square. So I hope it is clear that we have replaced v cos beta by u cos alpha, so that the square of it also becomes the square of this, right? So rather let us consider this as equation 2 now. Now subtracting these two equations, what I would get is equation 1 minus equation 2. I would get minus m minus n is equal to, it is a tan alpha minus a tan beta, a tan alpha minus a tan beta, and I have not written the next term because these two will get cancelled, right? So it becomes m plus n is equal to a into tan beta minus tan alpha. I have multiplied with minus sign on both sides, so we'll get this. But as we can see from the figure that m plus n must be equal to the height of the tower, so I can replace it with h. So I got h is equal to a tan beta minus tan alpha. So this is what was asked in the question, where it was asked what is the height of the tower if this was the condition or the point at which they are meeting. Thank you. So here we shall consider another application of projectile, but this time it is a horizontal projectile from the top of a tower of some height, say 4 meters. But here the point to be noted is we are having an inclined plane which is at an angle of inclination 30 degrees, and the projectile has to hit this inclined plane normally, that means at right angles. So let us say it is hitting at this point of P at right angles. So for this to happen, the question is, what must be the initial velocity of the projectile? And the data which is given is only the height is 4 meters for the tower and the angle of inclination of the inclined plane is 30 degrees. So before we proceed any further, we have to make some assumptions so that the calculation becomes more easier, right? So here we will assume that the plane, this line of the inclined plane, the surface of the inclined plane is making the x-axis, so that this will become y-axis at 90 degrees. Okay, so now if that is the case, we will have acceleration due to gravity, which is resolved into two components. Obviously, along the negative x-axis, the acceleration would be g sine 30, because if this is 30, this must be 30, and if this is 30, this must be g cos 30, and this must be g sine 30. So the component normal to the surface, that means along negative y-axis, must be g cos 30, and the component along the negative x-axis must be g sine 30. Okay, and now coming to the velocity, it was given that the projectile is projected horizontally with a velocity u, so that even this I have to resolve along x and y axis, so that I would say if this is 30, this must be 30, and this component would obviously become u cos 30, and this component which is along the negative y axis must be u sin 30. So let us assume that it was at time 0 seconds when it was projected, and it hits the this inclined plane after some time t seconds. So let us say this is t seconds. So from here to here, say from point A to point B, the projectile takes a time t seconds. So now if we consider the equation V is equal to u plus at, and I consider this equation along the x-axis. For me, the x-axis is along the inclined plane, and let us also assume the sign convention that like this. This is positive, this is negative, okay, and along the x-axis it is positive, and along the negative x-axis it is negative. Okay, that means I have taken the regular notation. Positive x-axis direction is positive, negative x-axis direction it is negative, positive y direction anything would be positive, negative y direction anything would be negative, right? Now coming to Vx is equal to ux plus axt, that means I am going to take the components along x-axis. So you can easily understand that when it is hitting the inclined plane perpendicular to the surface, its component along the x-axis must be 0. So I would replace the left hand side as 0, which is the final velocity x component, and coming to the initial velocity, again the x component would be u cos 30. So I would say it is u cos 30, and quite obviously the sign convention should give it positive because it is along the positive x-axis. So that into t plus. Now coming to acceleration along the x-axis is acting negative x-axis, so that it must be negative. So it must be minus g sine 30 into t. Oh, sorry. Here it is not t, by mistake I have put t. It is u plus ux plus axt. So it is u cos 30 plus acceleration is minus g sin 30 into t. So that now the time taken would be u cos 30 divided by g sin 30. So I would rather say it is u cot 30 by g. Cos by sin is cot. So it must be root 3 u by g. So I got the time by which this projectile would hit the inclined plane. Okay, assuming that to be hitting normally, right? So now coming to the equation of motion again, another one, which is s is equal to ut plus half at square. Okay, so this time I would rather take the y component. That means I would write sy, uy, ay. That means all the quantities I will take the y components. So while coming from A to P, what is the displacement along y-axis? So as per my sign convention, it must be negative. And how much in magnitude? So for that, we can consider this figure. So the same figure, just skeletal diagram. This height is here. And this angle must be 60. Obviously, if this is 30, this must be 60. And this distance must be the distance covered along the y-axis. So this is the distance. So this must be the opposite to 60 degree angle 60. So that it must be h sin 60. So I mean to say that the word displacement along y-axis, which is obviously the negative axis, is h sin 60. And as per sign convention, it must be minus. So I would write it is minus h sin 60 is equal to, coming to uy, again it is u sin 30 with the negative sign because it is also in the negative y-axis direction. So I would say minus u sin 30 into time taken. I have already solved for it, which is root 3 u by g plus half, coming to the acceleration. The component of acceleration along with the y-axis was g cos 30. So I would replace the acceleration as g cos 30 into t square. It is the same t, which is now root 3 u by g whole square. So now simply we have to solve. We can get the answer. So it becomes, first of all, wait. Just a minute. Here also g cos 30 must be negative because it is also along the negative y-axis. So it must be minus here. So the very first thing I can do is cancel all the negative sign on both sides. Cancel all the negative sign on both sides. We can write root 3 h by 2 is equal to u by 2 as sin 30 is 1 by 2 into root 3 u by g plus g by 2 into root 3 by 2 into 3u square by g square. The very first thing we can do is cancellation of root 3 on either sides. So this will cancel. So it becomes, and one more thing we can do, we can cancel also 2. So it becomes h is equal to u square by g plus, here also we can make a cancellation of g. 1g would cancel in the denominator. So it becomes 3u square by 2g. So it becomes 5u square by 2g. Taking the LCM, we will get 5u square by 2g. So h is equal to 5u square by 2g. That means u is equal to root 2gh by 5. Now it is given in the question the value of h is 4. So it becomes root of 2 into 10 into 4 by 5. So the numerator is 80. 80 divided by 5 is 16 and root 16 is 4. So I would get 4 meter per second. So I got the velocity with which the projectile has to be projected as 4 meter per second if it had to hit the inclined surface normally. Thank you.